Hello, everyone. This is another question. This is from 2020, May June, paper 2, variant 2. So here they are asking figure 2.1. Wait a minute. Figure 2.1 shows the thinking distance and the braking distance for a car driven at 100 km per hour. The car has old, smooth tires. Okay, they have given us the thinking distance and the braking distance. Thinking distance is 21 meter and braking distance is 75 meters. Calculate the total stopping distance. I told you before as well that total stopping distance is the sum of braking distance and thinking distance. So altogether 21 plus 75, it will give us 76, it is in 96 meters. Now the car is now fitted with new tires at a speed greater than 100 kilometers per hour. The total stopping distance is the same as in A. State and explain the effect that the increase in speed and the use of new tires have on the thinking distance. Effect and explanation. So here, use of new tires is related to the braking distance because tire and together combine gives friction. So if tire condition is changed, if tire is new or used, it affects the braking distance. Thinking distance is all about the driver and the speed of the car initially before the brakes are applied. Obviously, when car is moving at a slower speed, it will cover less distance before the brakes are applied. And if it is moving at a higher speed, so before the brakes are applied, while the driver is thinking, the car will cover more distance because it has more speed. So the thinking distance will increase, and the reason is that speed is increased and no need for and. This is the explanation. State and explain the effect that the increase in speed and the new tires have on the braking distance. So the braking distance will decrease. Why will it decrease? Because the tire is new. Now it will have more grip with the road. So when the brakes are applied, there will be more friction and the car will stop by covering less distance than before. So if it is covering less distance, it is stopping earlier. It means that it is covering less distance. If it is covering less distance, so braking distance will be less. Okay, this is the question from October November 2023, paper 2-1. A lorry truck is at rest on a straight horizontal road. A constant driving force of 5.4 exponent 4 Newton acts on the lorry and it accelerates forwards. Define what is meant by acceleration. It is change in velocity per unit time. As the lorry moves forwards, work is done on it by the driving force. So this part onwards is from the topic. which is work done. So it is here with us mixed with the dynamics. So we are doing it right now. So state the equation that defines work done. Refer to the direction of force exerted. So work done, the formula of work done is product of force and distance covered in the direction of force. So work done is the product of force and distance covered in the direction of force. Calculate the work done on the lorry by driving force when the lorry travels a distance of 280 meters. So work done is force into distance, and force is given in the question, and which is 5.4 multiplied by 10 raised to the power 4, and distance is 280. So if we multiply 280 by 5.4 exponent 4, it is 1.5 exponent 7. So it is joules, it is written there, so no need to worry. At one point on the road, the kinetic energy of the lorry is this, which is given in the question 3.2 exponent 6, and its speed is 12. Calculate the mass of the lorry. So the kinetic energy formula is 1 upon 2 mv square. Kinetic energy is given 3.2 exponent 6. 1 upon 2 mass is required and speed is 12 square. So mass will be 2 into 3.2 exponent 6, and 12 square is 144. So it is 444, 4.4 exponent 4 kilogram. So it was easy one. Okay. This question is from, this is the big one, 15 mark question from 2020, October, November, paper 2, variant 2. A bus leaves a bus stop at time t is equals to 0 and travels along a horizontal road until it reaches a second bus stop. Figure 7.1 is the distance time graph for the bus between time 0 to time 60 seconds. Okay. The road on which the bus is traveling is straight except for a short curved section. The bus travels around this circular curve. Circular curve is important here. We will understand it later. Why? Between time 21 to 24 seconds. Describe how the motion of the bus between 0 to 10 seconds differs from its motion between 35 to 40 seconds. So, guys, it's a distance time graph, and the gradient of distance time graph gives us speed. So, we can see here in the starting, the gradient is increasing. It means the speed is increasing, and from um, 35 to 40 is in between here. The gradient is decreasing. So if the gradient is decreasing, it means that the speed is decreasing. So it should be 2 mark, 3 mark. Okay. So I will write from 0 to 10 second, speed is increasing as gradient is increasing. From 35 to 40 second, speed is decreasing. Now this is a 3 mark question. So we have written here Uh, Speed is increasing and speed is decreasing 2 marks. He have secured 2 marks. And the problem is, what about the third mark? What? So we have to look into the graph to tell something more about the motion. So what we can check here that we can write here like it is starting from rest and then speed increases, or we can write here okay, when it decelerates, when the speed decreases, it comes to rest at 40 second because at 40 second the speed is zero. So if the speed is zero, because the gradient is zero, so for securing one more mark, we have to mention this as well. If this question were of only 2 marks, so this is enough what we have written so far. But right now they are demanding more, so we have to tell them more till it reaches at zero. Determine the maximum speed of the bus during these 60 seconds. So for maximum speed, remember about this that you can see here the speed is increasing and then there is a straight line which is showing that the speed is constant and then the decreasing gradient. So the speed will decrease. So during this straight line, like in the starting, the speed increased. Now it is constant. After this, it will decrease. So in this region, we will have the greatest speed because after this, the speed will decrease. So if we find the gradient of this straight line, so we will get the speed, and this speed is the maximum speed in this region because after this, the speed is going to decrease. So I'm picking 2 points here. One point is this, and let's pick some other point. Let's say this is the point that I'm picking right now. You can choose any point. Okay, so here it is 11, 12, 13, comma 100, and here it is 31, 32, 33, 34, comma 10, 20, 30, 40, and 50, 350. So these are the 2 points. So the gradient is y2 minus y1 over x2 minus x1. The max speed is the gradient of graph, or it is 350 minus 100, 350 minus 100 over 34 minus 13. What I'm going to get here, 250 over 21. So this is 11.9. So 12 meter per second is the highest speed here. The average speed of the bus between leaving the first bus stop and arriving the second bus stop. So here average speed, the formula for average speed is total distance over total time for covering this distance. So the total distance is covered is basically 390 and the time it took to cover this distance is 40 seconds. So it's 390 over 40. 390 divided by 40. I'm getting 9.75. So it will be 9.8. meter per second. State how velocity differs from speed. So velocity is a vector quantity, it has direction. Speed is a scalar quantity, it does not have direction. Velocity has direction while speed does not have. There are three periods during the 60 seconds when there is a non-zero resultant force acting on the bus. They are saying non-zero resulting force, which means that there is acceleration. So complete the statements to indicate these three time periods and state the direction of the resultant force on in that period. So remember, we started like this. Between 0 to 10 seconds, the speed is increasing. It means there is acceleration, there is non-zero resultant force. So first of all, I'm writing here that from 0 second to 10 second, the direction of resultant. If the speed is increasing, then the direction of force is in the direction of motion. And from 35 to 40, you remember, speed is decreasing. Deceleration, and deceleration is negative acceleration. So if the acceleration is negative, it means the force is also negative. So the resultant force will be opposite to the direction of motion. Now, what is the third time? It is mentioned in the starting of the question. Where is it? It's here. For a short curved section, the bus travels around this circular curve. So this is the circular motion part. If something is moving along the circular path, there is always a force towards the center of the circular path, which is known as centripetal force. So, and they have mentioned it as well, the time that from 21 to 24 seconds. So here I will write 21 second to 24 second. The direction of resultant force is towards the center, or you can say perpendicular to motion. This is also a way to write it. Perpendicular to motion, because while performing circular motion, at particular instant, if object is moving like this, the direction of motion is this, then the direction of force is towards the center and it makes an angle of 90 degree. So these are the both ways in which you can write it. Now, during the journey, the air resistance acting on the bus varies. State why the air resistance changes during the journey. Because the speed is changing. If air resistance depends on the speed. If the speed is increasing, air resistance increases. If the speed is decreasing, air resistance decreases. So that's the reason why air resistance changes. On figure 7.1, mark and label with M a time when air resistance is a maximum value. When the speed is maximum, the air resistance is also maximum. So we identified that the straight line section has the maximum speed. So we will write M here. Now, the next question is from 2022, May June, paper 2, variant 2. Figure 7.1 shows the speed time graph for a car traveling on a straight horizontal road. Describe the motion of the car. So it's a 3 mark question, 3 segments as well. You can see here till it's a speed time graph. So speed time graphs gradient gives us acceleration. So from 0 to 10, the gradient is constant. It means that the acceleration is constant. From 10 to 20, the gradient is 0. It means that the acceleration is 0. And from 20 to 24, the gradient is constant again, but it is negative. It means right now the object is decelerating because the speed is decreasing. I'm writing here from 0 to 10 seconds, car has uniform acceleration. From 10 to 20 second, acceleration is 0. From 20 to 24 second, the car is decelerating. And one more point here to mention is the requirement is not fulfilled because it's a 3 mark question, but you can see this and this has a gradient difference. It's a more gradient when it is decelerating. If there is more gradient when it is decelerating, it means the magnitude of deceleration is more than the magnitude of acceleration. Using figure 7.1, calculate the distance traveled by the car during the 24 second of its motion. Show your working. So it's a speed time graph. In order to find the uh, distance, we need to find the area under the graph. So we can see here, it's a trapezium like this. So these are the two parallel sides A and B, and the distance between them is h. So the area formula is 1 upon 2 A plus B into h, if you guys remember. So here you can see that this is 24 and this is starting from 10 till 20. So this is 10 and the distance between these two lines is 16. So this is 16. So distance area under graph 1 upon 2 A plus B 24 plus 10 and the distance is 16. 24 34 divided by 2 multiply by 16 272. So it will be 270 meters in two significant figures. Calculate the average speed of the car during its motion. So the average speed is total distance per unit total time. Total distance covered is, we have already calculated, it is 272 and the total time is 24. So the answer is 11.3. So it will be 11 meter per second in two significant figures again. A second car travels at a steady speed. It travels the same distance as the first car in the 24 second of the journey. On figure 7.1, draw the speed time graph for the second car. Again, they are saying the second car travels at a steady speed. It travels the same amount of distance as the first car in 24 seconds. So it means the speed will be 11. That because we have already calculated that if a car is covering 272 meters in 24 seconds, it must have a speed of 11 meter per second. That we have already calculated. So we will pick up a point where we have 11, 12, and 8, 12. Now 8.4, 8.8, 9.2. Wait, 12 minus 8 divided by 5. So one box is 0.8. 8.8, 9.6, 10.4, 11. Is this 11.2? So this is the point. Okay. The thinking distance is the distance traveled by a car between the time that a hazard is seen and the time that the brakes are applied. We already know this. The braking distance is the distance traveled while the car slows down to rest. Table 7.1 shows the braking distances for an alert driver when the car travels at different speeds. Complete table 7.1. Okay. 9, 18, 36, 45, 20, 40, 60. The speed is increasing at a constant rate of 20, 20, 20. So the thinking distance at the speed of 20 is 9, and the speed 20 increased, it is 18. And here also 36, 45, it is following the table of 9. So it is obvious that 18 after this, it is 27. The time it takes for the driver to react to the hazard is constant at different speeds. Explain how the table shows this. Because as the speed is increasing, the distance, the braking distance is increasing at the same rate. If speed is getting doubled, the braking distance is also getting doubled. If the speed increases 5 times, the braking distance is also in sorry. The thinking distance is increasing at the same rate because it's about the driver. If speed is 20, it is 9. If speed multiplied by 5, it's 100. So 9 multiplied by 5 is 45. So the thinking distance is increasing proportional to the speed. So it means the driver is taking the same amount of time for applying brakes. As the speed increases, so the thinking distance also increases, but driver is applying the brake at the same time because if this changes, then it will no longer be proportional. So it's a 2 mark question. So first of all, I will write that thinking distance is proportional to speed. So if 20 is divided by 9, I'm getting 2.22. You know, when two quantities are proportional, their ratio is always constant. So 60 divided by 27, it's again 2.22. And if I divide 100 by 45, I will again get 2.22. So it means they are proportional to each other. That's why driver is taking same the time it takes for the reaction is same. It is proven by this. State what happens to the thinking distance and the braking distance when the driver is tired. If the driver is tired, it will take longer to apply brakes. So the thinking distance will increase. But brakes are not tired, so they will work work properly because it is not mentioned that the brakes are um, not working properly. So it will not affect the braking distance. Rather, it will affect only the thinking distance. So the thinking distance will increase, the braking distance remains same.